Okay, this is part 2 of your Kin 225 lecture for Monday, January 24th. So I think my dog made a brief appearance in the previous video. So here's a little dog and cat COVID type cartoon for you. The dogs are all happy because people are staying home with them now, and the cats are sort of pissed off. So for this video, I'm going to be talking about the force-velocity relationship. So again, this has to do with actin and myosin, your contractile proteins, and how force output might change with different velocities of contraction based on the interactions of actin and myosin. So this is your force-velocity relationship. So if you're lifting a weight, the faster you lift it, the less force you're able to generate. So you can see that force goes down in a curvilinear manner with velocity. And this is actually one of your labs. I think it's lab number 2 covers this, the force-velocity relationship. So out here you've got zero velocity. It's like an isometric contraction. So it's a contraction where you're contracting your muscle, but you're not doing any movement. So it would be like pushing against a solid wall, an immovable object, or pushing against a heavy car that's too heavy to move. You can generate a lot of force at zero velocity. And then as you increase your velocity of contraction, your force generating capacity decreases. So one question here is, why does ability to generate force decrease as velocity of contraction increases? I kind of gave a hint on my first slide, and that it has to do with actin and myosin interactions. So the bottom line is that myosin and actin are sliding too fast past each other to form strong cross bridges. So that is why your force decreases as your velocity increases. Again, with an isometric contraction at zero velocity, you've got very strong actin-myosin cross bridge formation because there's no longer that challenge of having that speed where the cross bridges cannot form efficiently. So how does this affect training in the weight room? So this question asks, how would months of slow velocity resistance training affect the force velocity curve? So I've got the 2 dotted lines there before training and after training for the changes in the force velocity curve. And so this would be typical resistance training. Usually we do resistance training at a relatively slow velocity when you're lifting weights. So to get at the answer to this question, you've got to think that your adaptations with training or your changes with training are specific to the type of training you do. So because this is done with typical slow velocities, this type of training, your force output or your strength is going to increase at those slow velocities, but not as much at the fast velocities. So the correct answer to this question would be C. So you can see that the dotted line is after training, the solid line is before training. Your force output has increased at those slow velocities, but at the fast velocities, they've probably increased a little bit, but not that much. So the problem with that is that a lot of sports are done at fast velocities. And so you need to develop strength at these fast velocities. So in a resistance training program, if you want to improve your strength at those fast velocities, you should do some high velocity movements in the weight room. And that's what I've got with this video. It's a demonstration of a perfect exercise for this called the power clean. And she's going to demonstrate really good form on the power clean here. So it's a quick movement. You're lifting a heavy weight up to your shoulder level. And it's basically resistance training with fast velocities. And I'm just going to run this video for maybe 30 seconds. So you can see it's so fast in this video. She's putting so much fast movement in there. She actually jumps off the ground to get that weight up. So perfect example of a common fast velocity weightlifting movement that's done in the weight room. Great type of exercise for a lot of sports. So things like football, any type of sport where you might be doing throwing and track and field, like javelin or shot put, where you have to generate, strength but at fast velocities. So almost any type of, a lot of sports would require this. And I've got a YouTube video link for you there, that you can look at that Power Clean video. So the next question I have up here is, how would months of training with the Power Clean affect the force velocity curve? So with the Power Clean, as in the previous video, you're training with high force but at fast velocities. So you're making yourself stronger at fast velocities. So the correct curve to pick from these choices is curve number B. So you're training out here at those fast velocities, and that's where your force output is going to increase. That's the dotted line, is after training. And this is what's required in a lot of sports, and that's why some fast velocity training would be good in the weight room.